I am Anuhya, and our project is PLC controlled automated conveyor belt. Our main motive of the project is to segregate the items with respect to color, size, and material and packaging them using automated machine, which reduces a lot of work in industries. Now, we will be showing how we simulated the project using PLC and SCADA. Firstly, let's see the front end part, that is SCADA.
I am Niveda and I have contributed to this project by doing half of the SCADA program. The software we are using for SCADA is Wonderware Indusoft. These are all the tags that are necessary for our project. Next, we have to assign input-output addresses from the PLC program to these tags in the main driver sheet. Now coming to the main screen, here there are two buttons. The exit button exits the program in run mode and the demonstration button navigates to the demonstration screen. Here we are taking 1 to 13 numbers as input. Each number represents a specific type of object as shown. In the demonstration screen, the main button navigates to the main screen. The start button starts the PLC program and the stop button stops the PLC program. Here, the input object can be selected by typing its number in this box, or we can take a random number from 1 to 13 by clicking on the box. Here we have taken two colors in object. In the visibility, I have given that this object will be visible only if it is a white object and until conveyor 4 is done. This part indicates that the object will move horizontally until conveyor 4 is done and its position is proportional to the value of the given expression. In a similar way, the letters move along with the object and are visible if the object is plastic, metal, or defective respectively. This object is visible if it is not defective and infrared sensor value is 1. It moves downwards along with the packaging timer. This object is visible after package is done and until either metal or plastic push is done. This object is visible until metal or plastic push is done or until conveyor 7 is done. When metal is pushed, this object is visible and moves horizontally. Similarly, when plastic is pushed, this object moves horizontally. The other black objects are assigned similar expressions with infrared sensor value 0. Now my friend Varshini will continue explaining the rest of the SCADA program.
This is Varshini. Here on clicking the white box, go to the resize. Here I have assigned the values so that the size increases accordingly as small, medium and large. For reference, go to the main screen. And similarly for the black box, I have assigned the same way. This is inductive sensor, which will glow if the material is inductive or else it goes off. Similarly, this is capacitive sensor. This also glows if the material is capacitive or else it will go off. In here, in case the material is metal or both sensors will glow. If the material is plastic, then both sensors will be off. This is infrared sensor. If the material is white, it glows, and if the material is black, it will be off. These are the three ultrasonic sensors. If the material is small in size, then the bottommost will glow and the other two will be off. If the material is medium in size, then these two ultrasonic sensors will glow and the upper one will be go off. In case if the material is large in size, all three will glow. This is a metal push button which pushes to the right side if the material is only metal, and this is the push button which pushes to the conveyor material to conveyor 9 if it is only plastic. And finally, this is message display box which shows how many number of products are packaged.
This is how we simulated the project. Now let's see how we implemented the PLC ladder logic.
Programmable logic controllers, PLC, are accurate to fault. Correcting errors in PLC is extremely short, cost-effective, and they are robust. The software we are using for PLC is Roxwell Software RSLogix 500, RSLogix Emulate, and RSLinks. In the main ladder, the start button bit will become 1 once we press the start button, and it will continue being 1 until and unless the process is done or the stop button is pressed. We can jump to another ladder or another subroutine from the main ladder. Now, let us move to the controls ladder. Here, we check if the conveyor 1 is done, and if it is not, then we turn on the conveyor 1 bit, and which in turn turns on the conveyor 1 timer of 2 seconds. Now, if conveyor 1 timer is done, then we turn on the conveyor 1 done bit. And after conveyor 1 is done, we check if the inductive capacitive sensors are not done, then turn on the inductive capacitive sensor wait timer of 2 seconds. After this, the same process repeats for conveyor 2 and infrared sensor and conveyor 3 and ultrasonic sensor. After the ultrasonic sensors are done, conveyor 4 is turned on and it runs for 2 seconds, resulting the product to reach the packaging section. The packaging time is turned on for 2 seconds if the product is not defective and they are packed in their respective boxes.
As Preethi said, we will on the packaging timer only if the item is not defective. Here we are sensing the objects using inductive, capacitive, infrared and ultrasonic sensors and identify the size, color and material of the object. We are considering an item is defective if the object is neither metal nor plastic. After packaging the item, conveyor belt 5 starts and runs for 2 seconds. Then if the item is metal, we will push the item into conveyor belt 8 using pushing mechanism. Similarly, if it is plastic, it will be pushed into conveyor 9 after passing through conveyor 6. If the item is defective, it straight away goes through conveyor 5, 6 and 7 and dispose the item at the end of the conveyor 7. Since we are simulating the project, we have given the sensor values in the simulation ladder such a way that for each item, the respective sensors will be turned on.